Class, this is question 47, and the instructions are to write and solve an absolute value inequality for this situation. And I think that's the important thing that we focus on is that I'm not looking for you to just give me an answer. This is a pretty trivial problem. But the thing we're really practicing here is this multiple representation idea. We're given this situation, and we want to come up with an equation that represents this situation and then solve that. So write and solve an absolute value inequality for this situation. At Acme Trucking, the average starting salary is $24,000, but the actual salary, I guess, for a new employee could differ, or actually it could differ by as much as $1,575. What is the range of salaries? So it's pretty straightforward, right? Taking $24,000 and adding 1575, $24,000 and subtracting 57.5, and that's the range. But we're focusing on our ability to write and solve an absolute value inequality. So I have another problem that I want us to look at first, and it's this. In my hallway, I have a thermostat that looks exactly like this. And you can see this is what the temperature is set to. It's set to 72 degrees. And then this is the actual current temperature. It is 72 degrees. But that's not always the case, right? The temperature eventually gets colder, and then that's when the system knows to turn itself on. So I wrote that this thermostat is set to 72 degrees, but the difference between 72 degrees and the temperature in the room can vary by as much as 2 degrees. So if I was to say set a variable here, I could say x is the actual room temperature. And I'm saying that the difference between the actual room temperature and 72 degrees can vary by as much as 2 degrees. Now, on a number line, the solution to this looks like this. Here's my number line. Here's the number 72 degrees. And on the high end, I could be at 74. And on the low end, I would be at 70 degrees. And it says it can vary by as much as 2 degrees. So on the extremes, I could be sitting here and looking at a room that was at 74. And down at the minimum there, I could be looking at the 70 degrees. So at my extremes, I've got a minimal temperature of 70 and a maximum temperature of 74. And the actual temperature X lives somewhere in between these two, right? So my X's live somewhere in between those two numbers. So I know what the answer is already, right? And I could write down the solution. But my thing is I need to come up with the absolute value inequality that I can use to model this. And then maybe looking at it this way will give me some insight on how to solve absolute value inequalities. So I could start with this. I could say, look, the difference in the temperature, like if X is my room temperature, the difference between what the temperature in the room and 72, right, in absolute value, that difference absolutely. I don't know if it's above it or below it. So I don't know if that would be a positive number or a negative number. I don't know if it's on this side or if it's on this side. But the difference between the room temperature and 72 can't be more than 2 degrees away, right? It can't go out more than 2. It has to be within that 2. It can go 2 above or it can do 2 below, but the difference in temperature has to be within 2 units above or below. So this is the absolute value inequality, right? The difference between the room temperature X and what it's set to, 72, has to be within 2 degrees. Um, so sometimes in computer science, my students will have a question where like go through a list of numbers and find or two different lists of numbers and find numbers that differ by 2. And the problem is sometimes if you grab one of the numbers and another, those numbers differ by 2. But if you're just comparing it and saying, is the difference equal to? Well, this wouldn't equal 2, right? This difference would equal negative 2. This difference equals 2. But both of those, oops, this difference equals 2. But in both of these problems, right, those two numbers, 3 and 5, or 5 and 3, they're both both 2 apart from each other. But the problem is I don't know if I'm figuring out the difference between two things, I wouldn't know which one's the larger one and which one's the smaller one. So x could be the 5 or x could be the 3. And because I don't know which one's the larger number and which one's the smaller number, right, we actually end up using the absolute value function, because that will tell us then, hey, if the difference in terms of their absolute difference between each other is 2, then we could see that. And in Java, there's a class called the math class, which is uninstantiated, but or you can use it without instantiating an instance of it, but it's just math.abs. So if you call math.abs and give it the two values that you want to know the difference between, it'll give you the absolute value. And if that difference is, we would compare those with the number 2. If the difference is 2, then we could use those numbers. But back to here, right? So I was trying to use this to illustrate why it is that sometimes we need to look at the absolute value of the difference. So if I wanted to solve this now, right, this is kind of where some insight comes in. How do I solve that? Well, on the lower end, we've got x minus 72 has to be, think about it. So we're down on the lower end. This is where we're sitting at right now. If we went down to this side, that difference has to be greater than or equal to -2. So we're on the case now where we're going down to the low side. So the x minus 72 has to be more than, going this way, it has to be greater than, more than this, more than -2. And at the same time, the difference between x and 72 has to be less than or equal to 2. So that's considering the positive side, right? It has to be less than if we went 2 away, less than. This has to be more than. And I'm not really concerned about this end because this seems pretty straightforward, right? You can see this x minus 72 is the same that we had in here. The less than or equal to is the same, and the value 2 is exactly the same. Where there's maybe a bit of confusion sometimes is on the lower bounds, right? What happens over here? This is still x minus 72. Oops, x minus 72, and that's not a problem because that's exactly the same. But notice what happened with the inequality direction. Because we went down to the left, we're now concerned with this being more than. So this direction of this symbol flipped, right? It was less than, but now we need to know that we're greater than or we're above that minimal value. And also the sign changed right here. This was negative and now this is positive. I'm sorry, it was positive, but because we moved off to the left, now that's negative. Now, solving this is, straightforward. I'm just going to add 72 to both sides. So I could say x has to be greater than or equal to, if I'm adding 72 to both sides, this becomes 70, right? So you can see that's the situation that's happening over here. X has to be more than or equal to that lower bound, and at the same time, x has to be less than or equal to the upper bound, which is 74 degrees. So let's go ahead and look at our original problem then. So we're going to come back to Acme Trucking. So if I was to think about this on a number line first, and I don't think that we always need to go from the situation to a graph first, but I think it's helping here. So here's my graph. Here's my average salary of $24,000. And above that, if I take the $24,000, oh dear, time for some arithmetic. I'll take the $24,000 and I'll add to it $1,575. I get the upper bound of $25,575. And on the lower end of that, I'll take the $24,000 and I'll subtract the $1,575. And on the lower end, I get this $22,425. Okay, so again, my extremes are I can be as high as 25,575, or I can be as low as $22,000 425, or I can be inside, so I can go this direction or I can go this direction. I can be more than the 22,425, or I can be less than the $25,575. So any point that lies in this region, right, is a solution. These are all valid x values, including the endpoints themselves. That's why I'm filling in these circles, because they're included. So my inequality looks like this. If x is an actual salary, let me write this down. So what is x? X is an actual salary. So if x is an actual salary, the difference between an actual salary and $24,000, right, is constrained by 1,000. Oh, what was the number? $1,575. $1,575. So I can be above that, or I can be above the mean or below the mean. The difference is within that amount. It's less than, the difference can't be more than that. The difference can't go outside of this region. The difference has to be less than those upper and lower bounds. When I solve this absolute value inequality, then I've got the lower end to think about. So here's the $24,000. I know that I'm the lower end because now I'm saying that that difference has to be more than or equal to negative 1575. And then on the other end of that, if I consider the upper bounds, the difference has to be less than or equal to 15,075. So solving this is pretty straightforward, right? We're just going to go ahead and add 24,000 to both sides. So on this side, we get that x has to be greater than or equal to $22,425. And on the other end of that, x has to be less than or equal to $25,575. So as long as x lives within that range, all of those are possible salaries that fit this situation. So we came up with the equation, right? This is our absolute value inequality, and we solved it as well. And I want to say that when you have a compound inequality like this, where it's less than, which meaning it has to come inside, less than, it's constrained by, it can't be above that or it can't be below a certain value. So it's the stuff in the middle. You can write that as one inequality. So this is a compound statement, but you can write it as this compound statement in one thing. The smallest value up here is this. This is the largest value. And the x values are those things that are in between. So I could say, let me write the smallest, 22,425. Let me write the largest, 25,575. And my x values are stuff in between. So the x's have to be less than that upper bound, but the x's have to be greater than this bound. And I know this is this is the number, this is the symbol for less than, but if you look at x's, right, this is saying the x's have to be more than that. So you can take and combine this into one statement, and you'll see that sometimes. But to be honest, I kind of prefer if you write it as an and statement. You can't combine or statements like this, but we can combine ands like this. I kind of prefer it if you just use the and, so I know that two things are true. X's are greater than the lower end, but also X's are less than the upper end. All right, well, I hope you found this helpful, and we'll just finish this problem here.